Welcome to Physics for Life Sciences at Delta State University, and here we are at the beginning, Chapter 1, Introduction to the Nature of Science and Physics. Physics goes back a long way. We just didn't always call it physics. Physics is essentially our attempt to understand the world at its most fundamental level. We used to call this natural philosophy, the philosophy of nature. And in the early days, it really combined everything we think of as science into one thing. People didn't call themselves chemists, they didn't call themselves architects, they didn't call themselves biologists. They were all doing the same thing, which is trying to understand the world. When we talk about physics, we talk about models, theories, and laws. So a model is something that we use to try and help us understand data. All right. A theory is something that we believe to be true based on lots and lots of data. All right. We typically don't call something a theory until we have data supporting it. Most of the time, people in the non-physicists, non-scientists confuse the word hypothesis and theory. These are two different words. They mean completely different things. So when you're making a guess and saying, I think this might be, that's a hypothesis. Once we get around to calling something a theory, we've demonstrated over and over and over again that the model we've developed to describe what's going on fits our theory. Once upon a time, just being about 100 years ago, we also tended to call things laws. And so this next semester we'll learn about Ohm's law. This semester we'll learn about Newton's laws. We'll learn about the laws of thermodynamics. Laws are theories that have held up over a very long time and been shown to be true again and again and again. Now, from my perspective as someone with a PhD in physics, there are no laws. There are just really, really, really good approximations. All right? So good that we'll never be able to measure, for some of them, any realistic difference between what the law predicts and the real world that it's trying to model out. Scientific method is one of the processes we go through to discover new things, to prove things we believe to be true, right? Scientific method is a process of making observations, questioning what makes the world work that we're seeing, forming hypothesis, testing it over and over again. You will see, if you pay attention to the physics literature, you'll see some hypotheses come up now and again. We may have found a new particle. And this has happened several times over the last few years, and we keep testing and we keep testing and we keep testing, and usually what happens is we discover that no, what we thought was a new particle was simply a statistical variation in the data, and further experiments failed to confirm the new particle. And in fact, as you do more and more and more, the statistical deviation in the data moves back to the expected norm. And so you'll see in the scientific method, we hypothesize, we test, we test, we test. All right? So there are a lot of things now that come and go fairly quickly as a hypothesis, and then disappear as we develop more data. And then there are other theories that come around, or other hypotheses that are proposed that the data begins to support. And the more and more and more we test, the more likely is this is true. So the scientific method is rooted in this. We form a hypothesis, we make observations, we make more observations, we continue to test, we construct experiments to test our hypothesis, we construct experiments to try and prove our hypothesis wrong. And that's one of the important steps, is trying to prove your hypothesis wrong. And so we go through all of that before we just say, yeah, this is good, we understand this. Fine. a few of the things we're going to be talking about this semester. Forces in motion, work and energy, mechanics, they all break down into several different topics. All of this in this group really spells out work done by Sir Isaac Newton, who you can see back here in this photo. So this big chunk of the first semester is due to Newton. And then we'll move on to fluids and dynamics, all right? And we'll get into thermodynamics. Thermodynamics is really the rise of the Scottish engineers during the Industrial Revolution and the work they did. And then we'll end the semester with oscillations and waves, with harmonics, with physical waves, and with how we hear. So first part of the semester is all Newton. Lots and lots of Newton. This stuff is a few hundred years old. And then we get into fluids and statics, fluid dynamics, oscillations and waves. This stuff is about 200 years old, 150 years old, right? Not nearly as old as Newton's work. And this is how we basically progress through physics as we teach it. We start typically at the beginning, which is Newton, and we work our way through. And next semester, the Industrial Revolution, you're sort of looking at this peaking late 1800s, and this in the late 1800s. And we'll start off the second semester moving on from there and gradually work our way forward to today. All right, and that's it for our introduction.